Can you see the shared presentation?
Yeah.
Okay. Okay.
Everything's
Thank you.
fine.
Okay, my name is Illés Sas. I'm technical director of Electromonitoring Ltd. And my research topic is to investigate the possible treatment effect on high-strength steel welded joints fatigue properties, cooperatively with the University of Miskolc. And sorry. Today presentation, my first target to take a short review on a criticality of the high strength steel welding joints, why it is so critical, and also how we are, what is our aims and methods for the post treatments of the welded joints. Based on this analysis, I also plan to present a developed experimental program and share some informations about the actually prepared welding specimens and actual results. What is compare the base material and also the effect of the post-treatment method. That first of all, if we consider that what is the criticality and why it is critical, the welding of the high strength steels, we have to use two approach. The first approach is the manufacturing point of view. Then in manufacturing point of view, the first and the main issue that the high-strength steels materials is really sensitive for the cold cracking. Therefore, it's requested a really narrow gap to keep the T85 time between okay, in some literature is between 5 and 10 seconds or 5 and 12 seconds. It is give a really narrow area from welding point of view. And also we have to apply preheating in case of the quantum tempered high strength steels material. The other problem in manufacturing point of view that low deformability, because if we compare the mild steels S355, we recognize that the elongation is less than a half or nearly a third of the S355. And then this deformability also we have to consider in selection of the welding wire when we set the welding technology. Based on these facts that the deformability is much lower and also that the preheating and the technology parameters, we give a significant higher residual stresses on the welded structures. Mainly we are dealing in my company with the heavy structures like the mobile cranes or transportation equipments where the thickness is mainly more or close to 10 millimeter till even 50, but we have some cases when we are welding 80 millimeter thickness of the high strength steels. Of course, that itself, the fourth point in manufacturing point of view is the weld geometry. Itself, it's not only effect in the high strength steel because the weld geometry with applied mag processes, it's give the same result in case of the mild steels, but due to previously the lower deformability and the higher residual stresses, that these structures are more sensitive for the weld geometry, exactly the weld toe, what is also the weakest point of this structure. And based on this manufacturing, also we can, if we take consider the operational point of view of these welding joints, then many cases, like in mobile cranes, the welding joints itself give a fatigue load, and also based on the preliminary analysis during the design phase, it's planned to move the welding joints out of the highest critical areas, and that is how we are able to avoid the high fatigue loss on the welding joints. The other problem, but it's basically somehow it's coming from manufacturing point of view, but also it's considered sometimes in operational phase of the structures, that the delayed cracking of the hydrogen cracks. In our practice, in some cases, a week or 2 weeks after the welding, we recognize cracks. And during the operation, under fatigue circumstances, also can be recognized delayed crackings in the welding zones. Therefore, for example, in operational and also in a manufacturing point of view, we are applying non-destructive testings, what is implemented lately 2, 3, 4 days after the welding to find out the delayed crackings also. And here also we have weld geometry imperfections effects that in some operational equipments we can recognize later imperfections, and these kind of imperfections can also influence on the fatigue strength of the seal structures. There is some examples of the produced weld structures when you can also see that in manufacturing and also in the operational point of view, there are really critical zones like these ribs where we have three-dimensional strength properties, and also we have heavy plates where we have this cross sections where it is the most critical in this area. Also, then is some cases when we have in the corners also finding defects. What has the weld toe area has really effect on the fatigue properties. If we move forward to the post-treatment methods, that first of all, I want to open that what is the aim of the post-treatments, what we are investigate in my research topic. That the main issue is to improve the fatigue strength of the welding joints. That is basically applying with two approach. The one approach is that we want to reduce the severity of the weld toes stress concentration by reforming the weld toe to eliminate the imperfections and give a much smooth transition between the weld surface and the material surface. The other methods where we are also applying post-treatments is the residual stress reduction methods, where the target is to induce the compressive residual stresses in the weld toe zones by applying different methods. What is important in case of the post-treatment, that some of the post-treatment can be applied also not only after the manufacturing step, also lately when we are detecting imperfections during operation. And if we make an analysis, and based on the analysis, it shows some criticality of these imperfections that can be also applied post-treatment on the operation during operation condition to increase the fatigue strength of the fatigue life of the product. Based on this, if we can call weld geometry improvement methods and residual stress methods, what we are applying in a high strength seals material. Sorry. And based on this analysis, I make also some studies from different to investigate different post-treatment methods, and we start to develop our experimental program setup. What is based on three main influencing parameters. The first influencing parameters is the welding technology, but it's basically, of course, that it's influenced by the steel grade, the welding process, the welding position, the welding condition, and also it's important that the welding technique, what I'm calling this the cover layer, because in case of the cover layer, if we talk about heavy plates, then it's a multi-layer techniques, and not only between the material and the welding metal, we have a weld toe. Also, we have weld toes between the layers, what has also influence on the fatigue life. The other main findings in our preparation of the experimental program is the welding specimens, the effect of the welding specimens, that if we develop different kind of welding specimens, then we can compare the effect of the post-treatments in different type of welding joints. And of course, itself, for the experimental program point of view, the post-weld treatment itself, what we are investigating, it is also the most significant parameter. Based on this, we start to develop welding inspection program. What is we first of all we define the specimens, what kind of specimens, typical specimens, what we are able to investigate, and then you can see here that for different kind of welding specimen setups, also we have to divide these specimens between the butt weld and also with butt weld and fillet weld type. And also in the welding technique, what has influence in parameters, that is with the single layer and multi-layer technique. Based on this, we develop welding specimen post-weld treatment matrix for the investigation, further investigation, where you can see that specimens type, welding joint type, and the layer techniques, and also the weld geometry improvement and residual stress reduction methods. Actually, you see some green dots here. That is our actual scope of the investigation to start to compare the effect of the different post-weld treatment methods in selected weld specimens type. And based on this, we we start to prepare the weld weld specimens, what is made from Alfom 960 thermomechanically rolled high-strength seals material in 10 millimeter thickness plates. You can see the setup here. That basically what is important that during the welding we try to simulate as a rigid structure. Therefore, we apply that fixing the plates to avoid that can be freely deformed. That has also influence on the residual stresses. You can see here the welding main welding parameters. Also, we are welded with 4 layers in the product, the welding specimens. And then we apply, actually, we start the investigation with the residual stress reduction methods with needle peening and HIFIT high frequency mechanical impact treatment. You can also see some photos that the top photos is from the needle peening method, where along the welding lines we are applying the treatment, but not only the cover side, also we are applying in a root side method. Here we can see on the bottom photos the HIFI treatment. After the investigation of this product with these specimens by visual, magnetic, and ultrasonic testing, with a satisfied result, then we start to prepare the test specimens for the high cycle fatigue loads. In case of each welded specimens, we cut 10 pieces from the weld area and 4 piece specimens from the base material. Actually, this is 10 millimeters square, 12 millimeter, the size of them, the specimens. We apply water jet cutting to eliminate any influence of the specimens preparation methods on the fatigue strength of the product. And then we finally give results when you can see that the base material fatigue properties and also the as welded material. And if you see that compared the base material with the as welded product, it's significant decrease detected. And based on after the post treatment, we can see a significant improvement in the methods. Actually, now we want to further investigate that what is the difference between the methods. Here you can see it with the blue is the HIFIT, and the red one is the needle peening effect. As a summary, that basically this presented methodology of to set the experimental parameters is developed to utilize to further investigation of the post treatments in different conditions, standardized conditions. And what we also find out that during the preparation of the weld specimens, we have to apply robotized technology to minimize the effect of the welding technology itself influence on the fatigue properties. And as I mentioned in the last figures, that it can be detected that resistance of the base material high cycle fatigue is better than the as-welded joint, and also we detected a significant improvement on applying the post-treatment. Actually, we have ongoing investigation, and then the next step, we plan to continue with the weld geometry improvement methods by TIG remelting and also with burr grinding methods. And thank you for your attention.